Episode 41, Build, Wood-Burning Stove. Our plans had included a wood-burning stove. Several thoughts. Fireplaces often just take warm air from inside your house and shove it outside. Highly efficient wood stoves exist that provide warmth and heating and ambiance. A stove would also provide an emergency backup heat source if needed. Due to the efficiency ratings and emissions, we elected to go with the Jotul 500 Oslo wood stove. In 2020, the EPA set an emissions limit of 2.5 grams per hour for wood stoves tested with cordwood. The Jotul F500 only emits 0.5 grams per hour, which is 1/5 the maximum. This stove also puts out 70,000 BTUs per hour. Remember, my boiler is rated to 110,000 BTUs per hour. When running the stove, we meet about 60% of my whole house requirement. The wood stove would be placed in the great room, just off the end of the dining table. I wanted the stove to be raised a bit from the floor so that it could be easier seen and easier loaded. I designed and built a platform that would distribute the weight of the stove across the joists underneath. I covered the supports with OSB and then covered the OSB with 1/4 inch cement board. I also placed OSB and cement board on the wall behind the stove. We needed to ensure that the stove had the appropriate clear space from combustibles. My stove will have the rear heat shield and double-walled pipe. There are 2 clear space requirements for the stove. The first is a hearth pad to catch any embers that might fall out, and the second is distance from the walls so as to prevent combustions. For the hearth pad, the Jotul F500 manual states that it only needs a Type 1 hearth pad, which is fireproof but does not require any R value. The owner's manual further states that the hearth pad needs to be 18 inches on all sides that open, 8 inches on sides that don't open. This results in a hearth pad of 66 by 51 inches for the Jotul F500. The heat clear space is shown in this diagram, with the wall spacing requirement of 14 inches from the side of the stove and 6 inches from the rear. Combining these 2 requirements would result in a clear space around the stove of 18 inches on the left and front of the stove, 14 inches from the right, and 6 inches from the rear. My entire tiled floor is a non-combustible hearth pad, as is the tiled wall behind the stove. As I have no walls close to the side of the stove, and in that my floor is tiled, my requirement simplifies down to the 6-inch clearance behind the stove. I went with Duratech dual-walled piping for the stovepipes. Do not mix manufacturers. Northline Express has a good product selection, link below. One of the items that Northline sells is a cathedral ceiling support kit. This is the square heat mitigating box that goes through your cathedral ceiling. These work really well. Here is the stove on its stand. Episode 42, Build, Design and Install Kitchen. We had worked with a Home Depot kitchen designer for our cabinet layout and the specifics of each cabinet. We then custom ordered the kitchen from Home Depot. When I wired the kitchen wall, I ensured that I had all the outlets placed for the eventual install. You can see here the fridge outlet left of the post, the 4 over-counter outlets, the microwave outlet up high, and the range outlet down low. The cabinet order arrived on a truck and the delivery guys brought it all inside. Once it was inside, they asked me to simply sign a form saying that I had received everything in the order. I was reluctant to sign until we opened every box and ensured that it was complete. I was finally satisfied and signed for the delivery. Now it was time to haul all the kitchen into the basement to get it out of the way while we continued our main floor construction. Once we had the tiling complete, it was time to move forward on the kitchen install. The installation was conducted in 4 phases: mounting the wall cabinets, assembling the kitchen island to include wiring and plumbing, placing the granite top on the counters and islands, and installing the appliances. Phase 1. Mounting the wall cabinets. Step one was to haul the entire kitchen back up from the basement. This was quite a chore, tilting the boxes on the stairs and pushing them up foot by foot. I guess I need to get my exercise somehow. We began above the fridge, deciding what the top and bottom height of the cabinets should be. Once this was established, we mounted the above fridge cabinet and then the wooden vertical divider between the fridge and the cabinets. We then placed all the floor cabinets where they belonged, securing them to the wall. I then laid 2x4s on them to act as a platform so I could place the upper cabinets. I built a frame that I could set the cabinets on while placing them. This could be called a poor man's cabinet jack. The height of the frame was about 1/4 inch short of the needed height, and I used wood shims to raise the cabinets to their desired positions. I then screwed the cabinets through their frames into the walls 2x4s using cabinet screws. You can see that I've cut the microwave outlet box hole in the back of the above stove cabinet. The Milwaukee oscillating multi-tool I was holding was one of the most valuable tools I had for the build. I used it frequently. Phase 2. Now it was time to assemble the island. We first had to figure out how all the parts of the island went together. We had numerous cabinets, spacers between the cabinets, corbels, and other items. The corbels are supports that jut out from the cabinet to support the countertop. Once we had got a good plan in our heads, we then drew on the tile the placement of each cabinet. We began with the most complicated island item, the undersink cabinet. As mentioned in the plumbing segment, this cabinet required an island vent, which both enters and exits from the bottom of this cabinet. The undersink cabinet also required electrical outlets for the food disposal and any other item that might need electricity. This undersink cabinet also required a specialized cutout for the type of sink that we had chosen to install, a farmhouse sink. These sinks have dropped faces that go over the cabinet front. After we had the undersink cabinet placed and properly plumbed and wired, we then installed the remainder of the cabinets and corbels. This is the island before it receives the granite top. Phase 3. Place the granite top. We had purchased a nice slab of granite several years earlier and it had been sitting at a local warehouse. Now that we had our island constructed with the wall cabinets in place, the granite installers came and laser measured their cuts. They cut and installed the slab with no issues. The countertops looked great and we were ready to install faucets and drains. One of the cool items that I decided to install was an air switch for the food disposal. The switch is a small round button on the top of the counter. The switch operates by air pressure to a switch under the sink. Using a switch like this keeps electrical power away from the top of the sink and it removes the need for a disposal wall switch. Phase 4. Installing the appliances. We purchased all the appliances from Lowe's, receiving a significant package discount. They were all from Samsung. There were a couple of hiccups during the process. First, during delivery the guys damaged the front of the stainless steel refrigerator and then attempted to simply give us the damaged fridge. We refused it. Lowe's was very good and promptly provided a replacement model, which was an upgrade at no additional cost. Next, shortly after the install, the dishwasher began to leak, and I attempted to work with Samsung for replacement. After multiple calls and hours of arguing and bringing in my own plumber for verification, Samsung refused to honor any sort of warranty. Lowe's once again came through for me, and although I didn't receive a full warranty, they sold me a replacement dishwasher at a significant discount. Having a Lowe's Pro account and a working relationship with the guys is really helpful. The other appliance installs were simple with no issues. These included the fridge, range, microwave, washer, dryer, and utility sink. Episode 43, Build, Exterior Siding and Soffit Fascia. We had the famous Tyvek exterior siding on the house for about 2 years until we got to the stage of placing real siding over the Tyvek. We had any number of options for siding. Some of the more common are wood, aluminum, hardy plank, LP SmartSide. We wanted a siding that had the following characteristics: relatively easy to install, long life, low maintenance, easy repair if needed. Pros and cons. Wood, pro, easy install. Con, high maintenance. You got to paint it every now and then. Aluminum, pro, it's fairly common with low maintenance. Con, it's a generic look to the house. Hardy plank, pro, it's long-lived. Cons, it's a difficult install with silica, masks, you're cutting concrete. It's difficult to repair if damaged, and it's heavy. LP SmartSide, pros, good collection of colors and textures, relatively easy install. You do need to seal the nail holes and ends, long life, and easy repair. Based on all of these, we went with the LP SmartSide. We elected to place normal siding below the eaves and then shakes under the eaves. We began by placing Versetta stone, flat ledgestone panels around the lower part of the house. These panels give a nice look, protect against impact damage, and protection against snow and water damage. The installs begin by placing a drip edge below the bottom rock, putting an additional water barrier on the house, and then installing the rock panels. The panels looked really good when done. Now it was time for the LP SmartSide install. The main consideration with this install is that every exposed board end and every nail hole needs to be sealed to prevent water intrusion. Other than that, the install is very straightforward and the result is magnificent. As you know by now, we used SIP construction for the exterior walls and roof. One challenge with the roof is that a 12-inch thick SIP is a non-standard size for fascia and soffit. The SIP is 12 3/4 inch top to bottom, and the depth of the fascia is about 12 inches. For the perimeter, we needed about 350 feet of fascia at roughly 12 inches high. The soffit varied. We needed 100 feet of 30-inch depth and 230 feet of 25-inch depth. I couldn't find pre-made soffit fascia that met these requirements, so I simply purchased rolls of 29-gauge forest green steel and made my own. I purchased 14 rolls of 50 feet each. To transform the roll of steel into the fascia, you need a roofing brake, which you can find at some lumber yards. One of the cautions is that many of the brakes are not durable enough to bend the 29-gauge steel. They are fine with aluminum, but fail when they try to make a nice 90-degree bend. I started at a lumber yard planning on using theirs, but it didn't work at all. Across the street was an HVAC business, and he had a brake. It was extremely tough, and we were able to bend the 350 feet of steel in no time. We installed the fascia in the soffit, and we were good to go.